Hey guys, it's Cindy, and today I'll be talking to you about electromagnetic radiation. Firstly, I'll be talking about Maxwell's equations. He has 4 equations, and they include Gauss's law of electricity, which states that the electric fields leaving an imaginary case is proportional to the number of charges inside the case. The second one is Gauss's law of magnetism, which states that the magnetic field entering an imaginary closed space is 0. The third law is Faraday's law of induction, which states a changing magnetic field induces a current. And lastly is Ampere's law, which states that a changing electric field generates a magnetic field. Electromagnetic wave. This is a diagram of an electromagnetic wave. It does not require a medium and has a changing electric field which induces a magnetic field, constantly self-generating. And finally, the magnetic field fluctuates perpendicular to the electric field. Heinrich Hertz is the one who proved EMR existed by attaching 2 electrodes to a conductive wire. He applied voltage across the wire, causing it to spark, generating an EMR wave from the transmitter. An unpowered receiver was brought close to the transmitter and began to spark, proving EMR has traveled from the transmitter to the receiver. Speed of EMR. It was found to be that the speed of EMR is 3 times 10 to the 8 meters per second. Heinrich Hertz proved a standing wave with an EMR with a known frequency and used an antenna to measure wavelength to find its speed. Michelson interferometer. He calculated the speed of light by sending a light towards an 8-sided mirror, which was then reflected onto a mirror 35 kilometers away. He approximated that the speed was 2.997 times 10 to the 8 meters per second. And lastly, Maxwell used electric and magnetic permittivity and derived an equation to determine the speed of light of EMR. The equation he proposed was that the speed of light in a vacuum is equal to 1 over root epsilon mu naught, which equaled about 300 million meters per second. Applications of electromagnetic radiation. Polarization decreases light intensity by filtering out the y-axis of EMR. Only half the intensity emerges from a polarizer, therefore the light becomes one single plane. Liquid crystal displays uses 2 pieces of polarized glass to block or pass light through the monitor. There are 7 spectrums of EMR: radio waves, microwaves, infrared radiation, visible light, ultraviolet rays, X-rays, and gamma rays. Radio waves have the lowest frequency and the longest wavelength, are 3 to 3000 Hz, are used in military and navigational applications, and are used communicationally in AM, FM radio, TVs, and wireless phones. Microwaves range from 300 MHz to 300 GHz. They transmit information in radar equipment, can cause water molecules to oscillate at their natural frequency, which is 2450 MHz, and they are used in GPSs. Infrared radiation ranges from 3 times 10 to the 11 to 3.85 times 10 to the 14 Hz. It's used in night scopes and satellite imaging and transmits heat from the sun and other radiators which cannot be seen but are felt by the skin. Visible light ranges from 3.85 times 10 to the 14 to 7.7 times 10 to the 14 Hz. This is, like the name says, light we can see, and it covers colors from violet at 400 nanometers to red at 700 nanometers. Ultraviolet light ranges from 7.7 times 10 to the 14 to 2.4 times 10 to the 16 Hz. It ionizes atoms by knocking valence electrons free and is emitted by the sun, activating vitamin D synthesis, therefore causing skin to tan or burn. UVA has the longest wavelength and can cause cancer, while UVB has medium wavelength and can still cause cancer, but UVC has the smallest wavelength and is blocked by the ozone layer. X-rays range from 2.4 times 10 to the 16 to 5 times 10 to the 19 Hz. They ionize atoms and molecules and are used to view images of bones and other objects inside the body. and are emitted by electrons outside the nucleus. Gamma rays range from 2.4 times 10 to the 18 to 2.4 times 10 to the 21 hertz. They have the highest frequency and the shortest wavelength, which causes them to be very dangerous. They can be used to cure tumors, and they are extremely radioactive. I hope you guys found this video informational, and if you guys have any questions, you can leave them down below. Thank you.